Payment is equal to the outstanding balance after the last full payment times 1 plus I. So I'm going to use that formula to calculate the last payment. Okay, you should have copied this already. So you says Petro pays 7,500 per quarter on a loan of 75,000 rand. Hey, the interest rate on the loan is 8.2% per annum compounded quarterly. How many payments will Petro have to make? So here we need to calculate N. Okay, how many payments? So that's N. Okay, all right. So which formula we're supposed to use for the first question? Is the one for present value. Why present value? Because he's going to pay back 7,500 after every 3 months. He borrowed, okay, 75,000. Because there is a loan involved and there are regular payments made at regular intervals, it's present value. You can make a mistake of using the future value. So be very careful. You use the future value if there is an investment involved. Use the present value if there is a loan involved. Right? So for D1, we are using the present value to calculate N. So first thing, write the formula P equal to X times 1 minus 1 plus I raised to the power of minus N all over I. So our P here is 75,000. Okay, X is 7,500 times 1 minus 1 plus I is 8.2% per annum compounded quarterly. So that's 0.082 over 4, right? We raise that to the power of, well, we don't know what the n is, so this will be minus n. Well, that's the one we want to calculate. All over 0.082 over 4. Okay? The question says how many payments? Remember, the n in the present value formula is not the number of years. It is the number of payments. How many payments were made? Right? So remember, from this formula here, you want to calculate n. So the first thing, just to remind you, we have to multiply this value by P. The product, we divide it by 7,500. Remember that. Okay. So allow me to do that here. 7,500 times 0.082 over 4. That product we divide it by 7,500 and it will be equivalent to 1 minus, let me use a circular bracket, so that will be 1 minus 1 plus 0.082 over 4, 4 raised to the power of minus n. Can someone simplify what's on the left? Yes, do you have a question? What's your question? Okay. This guy, his name is... I'm talking about the guy in the question. His name is Petro. Okay. He paid back 7,500 per quarter. A quarter is 3 months, right? So he paid back 7,500 every quarter on a loan, right? He had borrowed money which was 75,000. So the amount he borrowed, that's P. X is this 7,500, right? Since the compounding period is quarterly, we divide this interest rate by 4, because there are 4 quarters in a year. So that's why I divided by 4 here. I converted the interest as a percentage to a decimal value. Right? I hope you are familiar with the formula. This is the formula. This one here. Which over the weekend you're supposed to have used going over your own questions. All right. Do you understand? Right. I need someone to tell me what's the answer here. Can you stop talking? Can you convert that to a common fraction? 41 over 200. Okay, let's move on to the next page. 41 over 200. Wait. Please be aware that this is an age. Alright, I need to tell you now. So you get 41 over 200. Did you get that, all of you? That's equal to 1 minus 1 plus 0.082 over 4, all raised to the power of minus n. Then, when you get here now, you have to take this whole term here. It's negative. You take it to the what? To the left of the equation. Then you take this 41 over 200 to the right. If you do that, you end up getting 1 plus 0.082 over 4, all raised to the power of minus n is equal to 1 minus that. Then you get 159 over 200. If you take the 41 over 200 to the right, you get 159 over 200. Right. Now we have an exponential equation. Right? This is the base. So you drop down the minus n to equal the logarithm to a base of 1 plus 0.082 over 4, right, of 159 over 200. Yes. Now, because 159 over 200 is between 0 and 1, you get a negative answer if you find its logarithm. That negative and this negative will cancel out. Eventually, the final answer must be positive. So what is n equal to? Okay, minus n first. Well, what's the answer on the right? Negative 11.31. Negative 11.31. Right, so we can say therefore n is going to be 11.31. But the question is saying how many payments? Says how many payments? So here, what will be the final answer? What will be the final answer? To be 12. Right. So n will be equal to 12 payments. How? Right, you see this fraction here, that's the 12th payment. This 0.31, it's a fraction of a payment. It will be equivalent to almost like 31% of this amount. You see this amount here? That's 7,500. That's the amount that the person will repay in full every what? Every 3 months. But the final payment won't be 7,500. It will be a fraction of 7,500. So in terms of the number of payments, the answer will be a 12. Yes. Because the last payment is going to be a fraction, okay, of the full payment. So the number of payments is not 11. It's what? 12. There are 11 payments of 7,500, but the final payment is not 7,500. It's a fraction. So the next question now, we are going to calculate that final payment, which is a fraction of this. So this will be the final answer here for this question. Okay, 12 payments. Right? Any question there? But remember, the question was not asking for the number of years yet. It was asking for the number of payments. Okay? Alright, so let's move on to the next part of the question. Now, the next part of the question says, calculate the value of Petra's last payment made 1 quarter after her last payment of 7,500. So after making the last 7,500, what was the final payment, which is a fraction of the 7,500? Now to calculate that amount, we can use this formula here, right? We know we may need to calculate the outstanding balance. Okay, we need to calculate the what? The outstanding balance. So, since we got 12 payments here, right, in total, but there are 11 payments that are made in full. We need to determine what is that, or what is the value of that final payment. So let's calculate the outstanding balance, right? Let's calculate the outstanding balance. So, for that 2, this is how we're going to calculate it. Remember, the outstanding balance is equal to P times 1 plus I raised to the power of m minus x times 1 plus I raised to the power of n minus 1 all over I. Now, for this question, our P we know is 75,000. 1 plus I is the interest is 0, okay, that's the interest part. 0.082. So that is 0.082 over 4 raised to the power. Now our M, since there are 11 full payments, our M is going to be 11, right? So that would be 11 minus X, which is 7,500, then 1 plus 0.082 over 4, all raised to the power of 11 minus 1. Please don't forget to subtract the minus 1 there. Over 4. So what is the balance outstanding? What is the balance outstanding? What?
So 258,
258,
87. 89.
right. Then, so when you're calculating the last payment now, it will be equal to this value, 2258,89 times 1 plus I, which is 0.082 over 4. Can you simplify that? Yes, this is 1 plus.
2,305.
2,305. 305.
Rounded off 20 cents.
20 cents. All right. I also want you to try to calculate it this way, just to check. So this is, are you getting this?
Yes.
Right. You can also calculate it from here. See this amount, this fraction here is 0.31. Okay, can you multiply 0.31 times 7,500? 0.31 times 7,500. I'm talking about an alternative way of calculating that.
131 times what? I got
Loop year.
2000 yeah.
Okay.
Yeah,
Did you get? Yeah. By 0.31 multiplied by 7,500.
Yeah, it's 2000. Yeah.
You get what? 2,000. Alright, so they are very close, but they will take
That's not
the
same.
No, they are close.
But it's not the same. It's not the same.
Okay, you are getting to 2,300 what?
25.
Yeah, there's a difference of about 20 rand. Alright, so okay, based on how I taught you, let's use the formula that I told you. So this will be the last payment. Alright.